Hello students, this is video 7.4 and your objective is I can determine the measures of angles and lines formed by chords, and I can inscribe angles and segments in a circle. Your Excel skills are U6 and U9. Alright, let's go flippers. So the first thing we want to talk about today is congruent chords. Alright, so congruent chords, very simply, are going to be chords that are congruent. So let's draw some. Here are two congruent chords. BA is going to be congruent to DE. Here we have it written out. BA is congruent to DE. As a result, that means that the arc lengths are also going to be congruent. So that means arc BA is congruent to arc DE. The next statement for congruent chords is going to be that congruent chords are going to be equidistant from the center point of a circle. So if BA is congruent to DE and they're both chords, then RC, which is a small segment here, is going to be congruent to CS. These two segments are congruent to each other because both BA and DE are equidistant from the center point C. The next statement we want to read is that if a diameter is perpendicular to a chord, then it bisects the chord in its arc. Here we have what that would look like. So over here we've got circle, let's call it circle B. Okay, and if you look at it clearly, we have a diameter, which is ST, goes to the center point B, and a chord, MR. And if you look at it, you can see that there's a perpendicular intersection here, and it's bisecting this chord, so MN is going to be congruent to NR. And if you look again, you can see that arc MS is congruent to arc SR. And the next statement actually says the converse, which says if a diameter bisects the chord, then it's perpendicular to the chord. Same idea. We look at an example, and I'm going to kind of zoom in on one here, and it says, well, what is the length of line segment RS in circle O? So here's circle O, and you can see RS here doesn't have a measurement, but over here you can see that this piece is 12.5, and it's also 12.5 here. Can write that in. And because these two are chords and they're equal distance away from the center point, we can see that. Same distance here. This also has to be the same thing. So that's all together going to be 25. So that's how long RS is, 25. And that would be this piece here. The next thing we want to think about is product. So the product of chord segments are equal. Product, you're thinking product, here it comes. So the chord segments would be, if you look at one chord, and that would be here AC and DB. So what I want to do is I want to say, take AC and I multiply them together, that's going to be equal to D times B. All right, so next we want to look at inscribed angles. And inscribed angles are going to be angles whose vertex is on the circle, whose sides are the chords of the circle. So let's draw a few of these. You need 3 circles. We're going to draw 3 different types. So there's our first one. We've got a vertex on the circle, and we've got 2 sides that are chords. So let's just try and draw 2 more. So there we have 2 more clear examples. There's a really cool property that comes up as a result of this, which is, so that means that the measure of an inscribed angle is half the measure of its intercepted arc. And this is how we write that. So if we think about the measure of angle B, so here's angle B here, it's going to be equal to 1/2 the measure of this arc over here, which is AC. So if we knew what arc B was, let's say it was 30, then we could clearly say, well, this arc over here is going to be 1/2 of it. That clearly has to be 60 degrees. Okay? So our next idea we want to look at is that an angle is inscribed in a semicircle is a right angle. So let's actually draw that in. If we look clearly here, we see that we have a chord that actually is the diameter, goes through the center of the circle. So this would be a semicircle arc. We throw that angle in there. So we know that this one here, this angle here is going to be 90 degrees. And we know that this inscribed figure here, this arc would be 180. All right, time for some examples. So let's look at example 1. It says in the diagram, the two circles are congruent. So the two circles that are congruent are circle O and circle R. It says NM, arc NM, and arc PQ are congruent, so what can we conclude? We can conclude that segment NM is congruent to segment QP, and they are both chords. Okay, so here's question 2. It says, what is the value of x? So here's our circle, and we're trying to figure out what is x over here. What is this entire measurement of this segment? If we look at the picture, we can see that this is a circle, and these are two right angles, and they're meeting at this line, so that's perpendicular. And these are congruent as well, which means they're the same distance from these segments into the circle. So this must be a chord that is congruent to this chord, therefore it must be 12. Question number 3. What is the measure of angle A? We're looking for angle A. Well, I know very clearly that if I look at this angle, that it's going to be half the measure of this angle here, this arc, that's intercepted, which is 116. So I'm going to say 116 divided by 2 would give me, 100 divided by 2 is 50, 16 divided by 2 is 8, so that would give me 58. 58 degrees is the answer. Let's look at number 4. What is the measure of x? So x is a side, so we're looking for that. So if you just kind of focus yourself on the circle, and all we look for is this segment here and this segment here. So we can pull out and identify really quickly, this segment here is 10. This piece over here is x. We don't know it, so we're going to say times x. And that's going to be equal to this segment over here, which is 9 times 6. We want to go ahead and multiply. X is clearly going to equal 5.4. Last but not least, here's your secret hot question. It says, what is the measure of angle A and B? A and B. Find both. Remember to work on your IXL skills, U6 and U9. Later.